But hey, I'm Morgan. I'm not here on time this time. Sorry, with for those of you who were here last time. I considered standing you up again and then seeing how many people would filter through two in a row, but I decided against it. So really, really feel horrible about that, but I'm glad to be talking to y'all. I am currently working at a startup that I won't be able to share too much about, and a lot of the bio and backstory will come through this talk. I'm just mainly talking about my career, which is a lot of personal information in it as well. I'm just going to dive in and we'll talk about it, and I'll leave some time at the end for questions and go from there. Yeah, so the systems I like to work on are systems where on one end you put in electricity, and on the other end you get some kind of emotional response, typically a positive one, if I'm doing my job right. And that's been the story of my career so far. I enjoy doing it. I come from Mountain Standard Time up by the Idaho border. If you've ever seen Napoleon Dynamite, it's the same geographic area, just in Utah, not in Idaho. I grew up super bookish, super nerdy, reading a ton all the time, and not actually very engineering focused. But then in undergrad, I sort of, became really enamored of this idea of like, well, what if the thing that I do with my life that makes me money and gets me satisfies my needs also has impact on other people, and and that has positive impact on other people. And I look back on the things that had made my life better and saw a lot of engineering in them. And so that is what brought me to engineering. However, I graduated undergrad with very few practical skills, and I felt like I wasn't sure I was a good engineer yet. So I went back. I was sure I was good at school. I wasn't sure if I was good at engineering, so I decided to do more school and see if along the way I would become good at engineering. That led me to a PhD. This is my capstone project in the PhD. I did several projects during the PhD. This is the last one I did. So I'll just play a few seconds of that. This is SCAN. It stands for Climbing and Aerial Maneuvering Platform, a robot capable of flying, perching, climbing, recovering from failure. That was my. How's the video and sound playing through? I realized I didn't hit the optimize button. So give me verbally if that's if it's great, say yes, and if not, then I'll reshare.
Good. Yes, we can hear the video.
Cool. All right. So yeah, so I did that, and the thing you'll note about this is that it was a lot of fun. I enjoyed doing it. This video got a little bit of YouTube play, and I thought that it was kind of entertaining. The applications that we were talking about were things like surveillance, which didn't feel great, and but also didn't feel very plausible. Like I just didn't see how this noisy little quadcopter would be with no battery life and very little robustness would be an effective surveillance method. And also we were talking about like search and rescue, which again I just didn't feel like it was really a plausible solution. It felt very much like it was. I thought it was a lot of fun to do, but I didn't, if I'm going to be fully honest, see that it was like really making progress against the things that we claimed it was going to eventually um, solve. So I wanted that was one difficulty with me in academia, or at least this particular track I had landed on in academia was I couldn't see the application coming fast enough. And then the other trick was I didn't naturally enjoy the process of writing papers. It was fine, but I didn't. Uh, I struggled to find like an authentic voice that would let me write papers in an effective way. And so I had an opportunity to go. So someone swung by who had been working at Disney Research. I didn't realize Disney had a research arm. Once I did, I found out that my professor knew one of the principal investigators over at Disney, and that was a connection that got me the job, which was fantastic. And I felt like here's an industrial lab, so there's a focus on putting things out, and also. Um, what I particularly liked about Disney is that um, if it was a cool robot, there was a good chance that that could make sense for the business, right? Because the business is about entertainment, so even if the functionality uh, being being cool is the goal that you're trying to do, felt like that was achievable. So. Um, When I arrived at Disney, they were just putting together this demo, which was sort of the early beginnings of the thoughts about what would become my major project there, which was Stuntronics. So I arrived and they had this set up, which was a kind of like little raccoon. It wasn't even a robot; it was an or not even an automaton. Well, it didn't have any motors. It was a passive. It had some springs and some gears, so I guess it was an automaton. But they had this little raccoon they would throw across the room.
Wow. Whoa.
Yeah, it was
Cool.
fun. And it was also this was also put together by a special effects team that we didn't work with again because it was so scary. Like everything was always about to like the launch mechanism would trigger unexpectedly and everything was breaking all the time and but it worked pretty well for the executives when they came through, so that was a good thing. I am in this picture. I am where am I? Oh, hey, why is it? Hmm? I am back there. I'm behind the curtains, pressing the button to propel it out there, and I was also helping out with behind the scenes like troubleshooting. I basically saw this when I arrived and was like, "This looks like the most fun. I would like to be associated with this in any way possible." The guy who's up front, to the left there is Tony Dohe, who I ended up working closely with my whole time I was at Disney, but a really brilliant, creative guy with a strong technical background as well. But anyway, I jumped in to help out. Um, uh, I was trying to figure out a way into that project that would allow me to justify having a PhD. And that presented itself as like, well, once you're in the air, how do you control what you're doing? And if you're not spinning, the answer is there's not much you can do to control while you're in the air unless you use aerodynamic forces. But if you are spinning, then there's actually quite a bit you can do. So this is a magic trick. This is a brick-shaped robot, which I called the brick. This is the actuator for release, which is me. This is a slot, which the brick will fall through successfully only if it's in a certain range of orientations. And then if you understand foreshadowing, you know that it goes through the slot. So yeah, it unscrews itself from I give it a spin and it unscrews itself and then it falls spinning and then it goes through the slot. And the reason it does that is because it has weights inside that are deployed at the right moment. So it knows how fast it's spinning and then it deploys these weights and then it does the thing that an ice dancer does where like when you throw your arms out, you slow down the spin, pull your arms in, you speed up, and that basic principle gives you a lot of stuff to play with. So we started combining these two ideas, throwing robot across the room and controlling the rate of spin, and that became this series of prototypes. That is just a stick, but we were so excited that it did backflips. It was just literally a 4x4 from Home Depot. But this one has a bend in the middle, so you can start doing inertia games and having control. And this one is, ooh, metal now. Uh, and two places to bend, so you can do a tighter tuck. There we go. And land on your back like anticipated. That was, um, so we started doing this series of prototypes that were starting to get bigger and bigger and give us the sense that maybe we could do this with a character of some kind. I think I have my blooper reel here. Yes, blooper reel.
Wow.
Yeah, and then yeah, sometimes it's never going to. Oh wait, it finally does. Yeah. Um, so really fun. Was one of the best times I've ever had at work. With just a lot of trying things out and letting them break and doing things that didn't slow us down. So then there was kind of this separate question of like you've got the physics and roughly the right scale being figured out, but what about the performance? And can you make something that looks like a superhero or a human being or some a character? And there was a we had this really brilliant special effects mechanical designer who was helping us on the project, and he was like, we were like, hey, could you build a humanoid robot for us, electric instead of pneumatic, and make it at the scale so we can start trying that out. He was like, I think what I should do first is build a like half scale version of it so you can start playing with that. And we were like, that does sound like a great idea, but how about you just build us the full scale one? And he came back a few weeks later and was like, I went the built the half scale one, which was not what we asked for. It was a direct disobedience, but it ended up being tremendously useful as he predicted, and we were really glad that he didn't listen to us. So this is the half scale one. It's a little guy, just like 3 feet tall. And we learned a ton from this. And we had like a good early proof point, and like we were showing it to some partners, and they were like, "Oh, that's really cool! Like reference footage. When are you going to do it with a robot?" And they're like, "Oh, okay. We're getting some level of believability out of this. Here's though like this was like maybe like a it was I think it was like the first week we had gotten it working, and we happened to have like in the cadence it was time for like a review by a bunch of people who were considering it for potential theme park applications. And so we brought them by and gave them the caveats that it was early days, and we threw it once and it worked, and they're like, "Can you do it again?" And we're like, "Oh, sure." The what we changed after this demo was we moved all the timing to be on board the robot and internally synchronized. Um, because during this demo, we had the timing was being streamed from a control station. And so what happened was it missed, I think, maybe just one or two packets, and that was enough time delay for us to get this result.
Oh, wow.
I don't know if it's a little dark, but anyway, he perched on the water pipe. The fire suppression system. So luckily the fire suppression system didn't go off. Anyway, you could hear that people were fairly like, despite the fact that it was not what we intended, people were fairly entertained, and we got budget to take it to full scale. So this is just a quick shot of the full scale rig we built to give you a sense of the how big that was. Um, and then we got the full scale electric figure as promised. There's a bunch of other things along the way, but we won't go into that right now. And started throwing the robot.
Whoa.
There it is.
Very cool.
This is the most backflips we ever did. Two, three, four, five. There it is.
Whoa.
That's a pretty one. This one we love so much. But we couldn't end up using. There's those non-rotation ones. I think I said at the beginning those are hard to control. Um, so we were able to do like it, like the if you control the way you pump when you're being launched, you can get front flip or back flip or no flip. And no flip looked super cool, but there would inevitably be some artifacts where there would just be a little bit of roll left over. And so the uh half the time it would do that really cool like stand in the middle of the air, kind of like be a superhero, fly upright, and then half the other half of the time it would do that, and but it would just over the course of it, it would slowly like tip over onto its side and it would look really stupid. And I don't know, I tried for 6 months to get rid of that and I couldn't. So we didn't end up launching with any of those still ones. But that one was a fairly generic figure. We eventually got enough confidence behind it that we could do something that was customized towards the character we were going to launch with, which is, spoiler alert, it's a Spider-Man. So we did another rev on the um, electric figure. I'm skipping over here. There were at least three revisions of pneumatic figures that I don't have video for. So there's a lot of prototypes that happened. This is all time between the Rocket Raccoon and the full scale prototype you just saw was a year and a half, and then within a year we had this next prototype. Sticking the landing for us. Oh, I skipped it. Sorry. Anyway, there was another prototype. You can see it online. I'll talk. Maybe I'll grab the video if we have time at the end. So that became a Spider-Man stunt show, which is still running uh, in California Adventure, and lots of fun. In the meantime, while that was being developed, we went and started looking at, okay, we can throw really high, we can control orientation while we're in the air. What can we do about the landing side of things? Can we actually um, have a robot that doesn't get caught in a net but actually lands in front of people? And so there's a series of demos around that idea. Sticking the landing for us started with landing this little stick. So what's going on here is you've got some duck and sand. They're responding to disturbances, and they're taking information from this little tilt sensor in the front. That's a 65-foot drop with a very simple robot. And this is like some mid-air ducted fan control. This thing was super scary if it ever got out of control. It would spin like crazy. 2, 1, stop! That was a big full size thing, and we needed to slow it down. We couldn't just absorb all the impact in the legs. Scaling laws don't work in your favor as you get bigger. So we had a water rocket on board that would um, slow the robot down significantly, as well as inducted fans. And then it would drop for a while. We'd fire the water rocket, it would come to a stop, and then it would drop the last 10 feet, and we'd have suspension that would absorb it. So that was really cool. Great project. Kind of died in COVID. It was one of those where the team got scattered and reassigned to different things, and by the time we came back, it was, not going. This is a fun video of what happens when you drop it without the water rocket firing or the other systems. Not on purpose. There we go.
Wow.
Oh, that was good times.
Wow.
Yeah. So that's fine though. Then my last series of projects at Disney, we were kind of chasing this idea of how do I want to say it? There's a lot of humanoids now, and there were some then. Uh, what I like to say is that walking with a robot is really hard and technically challenging, but also it's boring. I very rarely see anyone walking and find myself entertained. So, good news, it's a really hard challenge, and more good news is it doesn't really impress anyone when you solve it. So I was looking at, well, are there ways that we can do systems that maybe are simpler and more robust, and maybe they can take one or two steps, but the point is not that they're good at walking. The point is that they can maybe walk enough to kind of provide the entertainment value or the give the believability of, yeah, I think this thing is can walk, but they are really good at falling down and picking themselves back up. So this was an exploration there.
Wow.
So this is we call this one the tub thumping because it can get knocked down and then get back up again. And then here's a version where we're going to try and take some steps. So we got like two steps, and then yeah, it's fine. And then we had an idea of like, oh well, you know what is actually sort of this asymmetric opportunity for robotics, which is if you put something on roller skates, it's a great two direct bidirectional win because on the one hand, people give you more allowance for not being good at it because we've all been on roller skates, and the first time you're on roller skates, it really is tricky. But then on the other hand, it's actually easier for a robot to do roller skates because we can, put a motor on the wheel and then we don't have to worry about the dynamic balancing of walking, which is something that people take for granted and don't think is impressive. So this is an early exploration of roller skate.
Oh.
Da, 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 da,
Wow.
da. We're up. And then we're gonna take our roller skating and oh no, which is fun. And that led to a roller skating rabbit. And this is some of the development work behind that one.
Ooh, that's cool.
Fun
Great.
one. So this was a fun. Oh, let me set this up a little bit. So we did. I think it'll come through on the audio, but we did this. Ended up doing this on the South by Southwest stage with the segment head at the time. Now he's the new CEO of Disney, Josh D'Amaro. And we had we had a few different tricks that she could do. She could climb out of the box. She could get herself up. She did that kind of somersault, and we thought that was kind of our big like our best kind of stage ready moment. And then she could roller skate, but not like extremely well. And so we were like, when we were thinking about how to get the robot off stage, we were like, we could try and like RC car the roller skates, but we're not sure how reliable it's going to be. So I was like, well, I just put her on my shoulders, and that's then that's like a little character moment, and then she's on my shoulders, we can get her off stage. I'm like, sure, that sounds good. And so it was like kind of just like it was like a technical mitigation thing, not like really a show thing that we designed. But then when we did it, I'll play it. You guys can see if you can hear it or not, but I'll tell you later. So she did her little somersault.
This is a phase of our development, actually, in this project where it's our playtime. Yeah. Because we're really trying to figure out what are the flaws and insecurities in this character.
So I don't know if you heard, there's a big like there's like 1,700 people in the audience all went oh at the same time. And so it was a nice like kind of surprise of like oh like you do all the technical stuff, but what matters at the end of the day is that there's some sort of feeling of connection um some sort of emotional connection between the human and the character. And so that was fun to learn. This is just some additional development work we did after that, which was working on kind of automatically transferring. You saw, I think in the earlier video, you saw some people wearing mocap markers. Tony was one of them, and just automatically be able to transfer that motion to the robot and have it work. And then we were looking at different ways of having her locomote, like this is a skateboard mock-up. Like obviously it doesn't look like skateboard, but like what if we put her on a skateboard? Could we kind of fake that motion? That looked pretty fun. And then there was, I think we have, oh yeah, pushing a cart. In this case, it's not motorized. It's I'm hiding behind the cart, but just seeing like, okay, can we kind of get some convincing walking motion if we control the cart? And it's like, oh yeah, that feels plausible. So our next thing uh, was a robot. Oh, and this is us like continuing to play with like again, can you get those like two steps in? And so those two steps, I think on the third one she probably would fall over, but like we got two steps, and so now we're starting to put together like can we put together an ecosystem that enables you to feel like this is a fully autonomous character, even though it's a very simple, robust robot? So we ended up taking all of that for our next show. We ended up doing a character from Zootopia, Duke Weaselton, as part of the Zootopia ride that opened in Shanghai Disneyland. So this is a video of that behind the scenes stuff. First robot I ever built that had eyes, and eyes make a big difference. Once you put them on, they're all you see. All right, it's getting away from there. Yeah.
Ooh.
It was a good time. So yeah, I think the if there's a theme of what I do, it's or well, I guess maybe to say kind of looking back over that career, I really think that the best things that have happened to me um, come out of this intersection of where you're exploring the edges of what's technically possible, where you have a strong creative voice in the room or voices in the room that are giving you insight, and then when you're physically mocking stuff up, so you're actually like just building stuff that you can see and play with and try. then that opens the door for serendipity, where it's where you can have stuff that falls out of that, like a roller skating robot, is this fun example of where you have something you're pushing technically, you've built something physically, and someone has the creative insight to be like, oh, you know what? Why don't we do this? And that would be really, really fun. So that's the bulk of my formal slides. I will also really quickly just jump over to YouTube. Um, Oh, that is the old Centronics video, but just a quick see if I think this video has it. Yeah, there we go. So you can see what that ended up being there. That's drama. There it is. Cool. That was a fun night. We were doing video shooting and or maybe it was separate. I can't remember if it was for the demo or not, but well, gosh, not what I wanted. Oh, now the zoom's in the way. But we couldn't throw the robot as high as we wanted to because of wind, and the executives were like, "Well, when will the wind be lower?" And I was like, that's not my responsibility." So, but I will say one thing about that. Just watching it reminded me. You get away with a lot when you're throwing something 65 feet in the air. It is a nice thing where in robotics, especially in like animatronics, we're always fighting the uncanny valley, where the closer, you add more and more actuation and you get something that's less and less appealing often. With the ballistic robot, you got this beautiful kind of parabolic curve, which you got for free, just out of gravity. And then you also, as you're twisting and flipping through the air, you get all these really wonderful like curves, sinusoidal motion, which again is for free and doesn't require you to have any actuation. And then just having the thing that makes when you're in the air, inertia is mostly driven by geometry. It's mass times radius squared, so that radius is the really important thing. So as long as you're kind of human proportions, you don't have to match human densities to have motion that you do look really physically plausible, like the way that you speed up when you tuck is really plausible. Because again, it's all so as long as you're matching the geometry, it's there. And then it didn't. So all that together means that the robot only has 10 degrees of freedom. Um, and it doesn't. I mean, like for instance, it doesn't have elbows. I don't know if you noticed that it doesn't have elbows. But we found we originally had elbows, and then we didn't notice it, so we took the elbows out. And so it's sort of this big, it's a lot of gross body motion. I think shoulder, shoulder, 3 degrees of freedom in the torso to get that really tight tuck. Hip, hip, and knee, knee, and then the neck. That's all you've got. Um, but it's because of all that extra physics that's happening, you kind of get this thing that's really um, elegant and organic and not too off-putting. So, uh, yeah. Anyway, that's me. That's stuff I'm working on. And then the last year and a half, I've been at Familiar Machines, which is a lot of fun, and there will shortly be a lot more stuff that's public about it. So, next time I can tell you more. But that is not yet true. So can't say too much about it except we're working on, similar things like, well, I like working in the character space and I like working on things that um, provoke positive emotions in people, and I also like working with multi-degree of freedom robotic systems. I think those are all true at this place as well. but I am doing a little bit more of a creative role here, which has been fun and a stretch in a good way for me. So big technical team that understands um, consumer products a lot better than I do, and I've been helping out on the getting the experience right, which has been a blast. So, but yeah, questions.
Oh,
Wow. Wow.
oh,
So
cool.
in
Yeah.
a theme park context,
Yes.
seeing something flying through the air and it's a superhero kind of thing, when you have a roller coaster or whatever, you have like these safety systems backup. So what if the evil nemesis points his ray gun at your thing and interrupts a couple of instructions so it goes flying off? Is there like, is
Oh,
there
you want to know about hazard analysis for for the
yeah,
robot? Yeah, I can
yeah.
talk to you about that. That was like the last almost, I don't know, at least 6 months, almost a year of like that was probably the bulk of I think I that was like my primary job for like maybe half a year. Was just making sure that like we could because there's two levels. There's is it safe, which is an important level. And then there's can you prove that it's safe or demonstrate that it's safe to the satisfaction of the right people, of the right legal team and all that stuff. And that's a whole different thing. So yeah, so with the thing that was that made this, I remember there was early on, we had been in R&D mode and we'd been pitching this to the Imagineering proper. And early on, there was this guy named Darren who came to a meeting and he told us later that his intention in coming to the meeting was to be the grown up in the room, and be like, guys, this is a nice idea, but it's never going to work, so let's kill it. And thankfully, Darren had an open mind, and we had also done by that time, we'd thrown things hundreds of times. And what's true about the physics of this setup is that it's on a rope. A rope doesn't push; it just applies a pull, and just in the one direction. So if the pulley is in a fixed point in space, there's only so many vectors that the robot can be accelerated along. And so we had done enough, like it always it always stays on this line of action. There's just no forces that are applied to the left, right, and anything. And there's a little bit of variation. Obviously, nothing's perfect, but like it was always along the line of action. So that meant that we didn't have to like we were. It was pretty easy to demonstrate that it wasn't going to go off substantially to the left or right based on the mechanical system. Um, we did have to do an eval, and so that kind of was like a baseline of like, oh, maybe this could work, right? And then there's mechanically it's not going to go off to left or right, but we still had to worry about air, the wind being able to push it off to one side or the other, and that's fun because we ended up developing a standard that was not based on the current wind speed. It was based on if you had the 2 minute average wind speed, what was the probability that you would get if current wind speed was X? What's the probability that you would see a gust of Y? Um, and so, in any 2 minute average that had X wind speed, we had the not me, but someone else had the foresight to put an anemometer on the roof of a building adjacent to where we were installing a year in advance. So we had a year of weather data to say for any 2 minute average, this is the maximum Y wind gust that was observed. And then you can do statistical modeling on that and say, okay, here's our human safety standard. What's the sixth sigma or whatever probability for wind speed that it's not going to go off the roof? So we did that. We have two redundant anemometers going on top of the building to make sure that they're both in agreement that it's safe to launch. And then there's the math of like how far it can go if like so we are on the line, but then if you put a lot of energy, you can go how far can you physically throw the robot? And that was technically the winch we got was very, very powerful, and there was some physical possibility of throwing it far, but it's also from a family of of well understood, like there's some safety rated PLC controllers that we use for things like roller coasters, where you can say, yes, it has this energy capacity, but here is the provably safe logic that shows that we're only going to achieve these velocities. And then we can do the worst case analysis of like what almost hits our limit but doesn't quite, and what happens then, and then you can show that okay, maximum distance traveled is this. There is, I will say, I had a hard time explaining to the legal team the difference between um, will not happen and is technically possible but will not happen. And so there's one extra airbag on the roof that that was a compromise where that there's an extra airbag behind and that will never be used. Um, but it made the lawyers happy. So we did that. But yeah, so there's and then there's like anyway, that's just like two of the that's some of the big stuff. There was infinite layers of that kind of stuff all the way down, and protocols for how you interact with the robot, how it's loaded, who's on the roof when it's launched and triggered, who's validating that who's on the roof, who has access. So yeah, so I would say that Disney is a unique spot in that I don't think there's very many places that there's places that would let you do stuff that's crazy. There's places that are very safe. There's a very small Venn diagram of people of places where you can do something that's that crazy and safe. So
Right.
Question in the chat.
There's a chat, the question in the chat from Christine.
sure. Let me look. Are there any open source tools I've stumbled across for multimodal actuation, e.g., light, thermal, and audio? Christine, do you want to
Yeah,
elaborate a little bit?
sure. I'm trying to figure out like bottom-up sensory interventions in a home environment.
Okay.
And so I'm curious if there's a way to like hack into like a Honeywell thermostat, for example.
Oh, yeah. Um, for like okay, sensing and feedback. I think almost everything I did have done so far has been uh fairly has been been mostly bespoke. We uh for that level of thing, um I'm think this might not be especially helpful, but um so I mean, well, no, yeah, common tools that we use when we're setting up systems like that are Touch Designer. I'm not very good at Touch Designer, but I tend to work with, but I work with a bunch of people who are good at Touch Designer, and that's like a nice graphical way to program different things, different inputs mapping to different outputs, and for like remote communication. It's not from this. Not, I don't think they're even that related, but they both have touch in the name. There's Touch OSC, which is a protocol for communicating between devices that's fairly robust and tractable. And I think there's um, a so yeah, I think there's a sound tool called Max that we sometimes use for communication. But I think Touch Designer is one tool that people use a lot when they're trying to just put together a bunch of different kind of inputs and outputs that seems to be pretty helpful. Again, I'm not an expert in it, but I've seen it come up over and over again.
Okay, awesome. Thank you.
Sure.
I have a question. I'm just curious. Going on some of the videos and stuff that I've seen, like I saw the Spider-Man video like come out when he accidentally hit the wall the one time. I've seen Olaf fall down the last couple of days and Olaf just like completely collapsed. What
Yeah.
level of like safety for the actual robot do you need to do? Like how much do you have
Ah,
to put in like to guarantee that you're not gonna break this like really expensive robot that you need to show and need to have every single week or every single day?
Yeah, that's a great question. Um, so yeah, there's if you're talking about risk, in that hazard analysis, you've got uh, it's levels of risk, and like number one is human safety, right? Like uh, that's number one. But then there's also uh, there's also like um, there's a risk of like financial impacts of like things that are expensive that are going to break and how much money is significant. And then one step below that, there's kind of like ongoing operational costs that are not really a risk, but there's something that will be taken into consideration for the budget of the project. So there's like how likely is it that you're going to do something that will break the robot and will require a big injection of money to keep the show running? That's a risk. And then there's kind of like ongoing maintenance. So with the Spider-Man robots, we intentionally we set expectations high on the amount of maintenance that would need to be ongoing. So there's more than one, we've delivered more than one robot, and the expectation was there'd be one operating, at least one spare ready to go, and then probably another one that was being like rebuilt, like just gone through and having all the screws checked and fixing anything that's broken or worn. And that would just be perpetually kind of on cycle. So we set the expectation high that there would be a lot of repair. But then we did do a lot of stuff to try and mitigate damaging the robot. So there's a whole airbag along the way in case the robot lands short. Obviously, the way we designed the net was pretty fun. That was designed by a guy from Cirque du Soleil who had Cirque du Soleil history. One fun guy, Scott Osgood, who had it's a special kind of net. It's tries to deliver a really even force load as you go, which is different from like a bungee, which will start soft and then spike, or a pure friction system, which will start very hard and then get softer. So it's a blend between the two systems. Um, in the specific case of and then I think for the nice thing about Olaf, I'm not in that. That all Olaf was just an idea when I left, so I was really happy to see it deployed. That's credit goes to the Zurich team. Moritz Becker is the guy who leads that team, and they're really really great, and they do the for real walking. Um, Olaf, I mean, one thing that I can tell you though, which is true, is that when you make a robot that's small, they tend to break less. It's just strength of materials works in your favor. It's the reason that ants can pick up sugar cubes, right? Like so smaller robots tend to break less, and smaller robots falling down tend to break themselves less. So, um, I'm sure they have similarly robust like spares and maintenance plans, but that Olaf falling down, that's not too scary. What might be surprising, the so there's two videos online of the Spider-Man robot hitting the wall. One is CGI and one is a real video. And the CGI one came out first, which was great because then when we actually failed, it was like the waters were a little muddy about like, is this CGI or not? Anyway, but you can tell the difference because if it's the CGI one, he hits the wall and bounces off the wall. If it's the real one, the wall collapses. And that's because we designed that section of the wall to be a breakaway. Um, uh, which was we had three design requirements in order of priority, which was number one, it needed to look like a wall because this is Avengers Campus in Disneyland. Everything needs to look nice. So that was number one priority. Number two priority was it needed to get out of the way if the robot hit it. It needed to collapse. And that's because we don't want, like, if Spider-Man is off camera by the end of a failure, great. The stunt person on the other end stands up, goes, "Woo, that was crazy," and we're on with the show. But if the robot is on camera, then we have dead Spider-Man on, like, which is not an acceptable state. And so it had to get out of the way. And then the third priority was, if possible, try and be gentle to the robot. And so we had actually done all of our testing with sandbags because we didn't want to risk the prototypes that we had of the robots. And so we didn't know, we had tried our best to design it to be fairly gentle on the robot. We didn't know what kind of damage we would have. We knew there were a lot of, like, you can't solve for everything. There's a lot of ways that different errors could stack up. We had proven that we weren't going to go too far. We weren't going to go off the roof. But going short, there's so many different ways that like something can go wrong and a brake can get activated, or something can get the robot can go short. We were fairly confident we'd eventually hit that wall at some point. So we knew it was probably going to happen, but we were super curious when it did happen, what the damage to the robot was, and it actually turned out it worked great. The robot, I think it cracked the one of the left calf shell, I think, got cracked. And otherwise it was back in service. So honestly, if it wasn't so expensive to replace, it's just a bunch of aluminum panels that form the breakaway wall. If it wasn't so expensive to replace those, I think it's a better show if we land on the breakaway wall. I would like to do that all the time. But yeah, that would be an ongoing expense.
I have one more question if that's okay. I also just, a lot of times when I see projects at like Disney R&D and like Imagineering and stuff like that, it seems like a lot of them are big question marks and possibilities that they might not actually like ever show up in the park. How do
Yes.
you like work on something knowing that it just might not actually show up or it might not like end? Like how, is it just the creative
Yeah.
want to get it done, or is there something that you're like, okay, this is work I kind of have to keep working on it, even if I don't want to, or I don't think it's actually going to show up?
Yeah. That's a great question, and psychologically, you'll get different answers from different people. I know a lot of people that I work with at R&D, or just in general in this space. They're more motivated by the day to day of they like solving the hard problems. They like doing something that's kooky and weird. They like pushing the boundaries of what's possible, and that's what's important to them. And so not that it doesn't matter because it certainly feeds back on the organization and on their careers, but like if it doesn't get out the door, it's like that's okay. Me psychologically, I do enjoy the day to day, but I very, very badly want it to go somewhere. And so this was a constant source of frustration. I was very lucky in that the very first project I got assigned to was this Spider-Man project, which is one of the rare projects to go all the way from conception to delivery and still be running in the park. So that was a wonderful, but I will say that was mainly a stroke of luck in that like that was the project I got assigned to when I showed up. And so trying to replicate that was tricky. And I was towards the end of my time at Disney, I was spending a lot more time trying to coordinate with other departments and figure out what they actually needed or wanted. Spending more time doing that than executing, just to try and find out like because that people problem of like what's actually going to be useful and valued was a trickier problem than some of the engineering problems I found. So yeah. Yeah.